So, my presentation today is a series of slides illustrating buildings which have taken advantage of two things. One is the climate, and secondly is the construction of the building, which is the building skin or the exterior of the building. By reducing the ingress of heat into a building, we can bring down its energy requirement for cooling. So here are some of the examples. And so this is my presentation largely to do with how buildings solve the problem of heat ingress. So my first example is a building in the Netherlands. It is a church, a repurposed church, which is converted to a public library. So churches have very thick walls, and so the heat doesn't come in. They have a very high construct. And so this church has been converted to a library with underfloor air conditioning and displacement ventilation. And so the thermal load of this building is substantially small. The library is full of people at different times of the year, largely in the evenings when the heat load is less. So, this is a museum in China which looks like the Egyptian pyramids. So, its walls are extremely thick. So, there are a few slits which allow light to come inside the building in a very pointed and specific way, but the building has low thermal ingress. Here is another building, which is a museum in Brazil. The museum is here, and this is the new part of the museum, but it has a huge foam concrete kind of a roof over a roof, which brings down the external load from the sun and looks like a low hanging cloud. This is the airport in Bombay. Many of you might have visited there. This is Terminal 2. This was designed by a very reputed architect in Chicago, Skidmore, Owings and Merrill. So this building has many advantages. First of all, it has inverted boxes for the ceiling, which admit diffuse light and also serve as a green roof. It has light diffused coming from inside, high exceeding roof, which gives shade, and built on top of a parking lot, which is green. It has huge amount of greenery around. So this building admits less heat, yet it is comfortable. The cooling is by displacement ventilation, which comes on and off depending on the occupancy and the carbon dioxide inside. Here is a botanical garden in Brooklyn in New York. This building is very large. It goes all the way to the back, and it is like a visitor center. It has an overhanging, shall we say, awning like this over there, which reduces the ingress of the sun, and a completely green roof, which serves as a walkway as well as protects the heat from coming inside the building. Here is a very iconic building in Seattle, in the state of Washington. It's a library. So it appears to be a building which will admit a huge amount of heat because of the glass, but the glass is very special. It has very low solar heat gain coefficient, so heat doesn't come in by transmission. And by clever cross shading of the whole construct of the building, even solar gain is far reduced, and it's a very comfortable building inside and encourages people to stay there for long, because when you're inside you feel you are outside because you have a clear view to all the spaces outside the building. So it feels good to be inside over there. This is a museum of African American history in Washington, D.C. It's not very old, it's just a few years old, and it is built to look like the crown of a headman of a tribe in Africa. They wore large, big crowns, probably made of gold. So the building has a skin of copper and brass. It looks like it is completely closed, but it emits light. It's like the second skin of the building, and protects the building from heat ingress, and has the complete open space, very few columns. It's a beautiful building. This is a building in the outdoors, a repurposed railway line in New York, which is not used. Above it is called the High Line, which is made for people to walk. And below is called the Low Line, where people can comfortably stay in the shade. And so it has lots of greenery, it has lots of light, it has natural shade. As you know, New York enjoys many months of comfort. And so this building is used by the public for, and we have a similar situation in Mumbai. In the city of Mumbai, if you go to Parel and some other places, the flyovers have been repurposed or purposed below the flyovers for people to enjoy sitting in the outdoors Comfortable because of cross ventilation and trees, and protected from solar heat from above by the very thick flyover. So we have outdoor spaces, which can also be called public spaces, which are used by people. And we have a cross section of population in India. So everybody needs a public space away from the sun in a more comfortable space. So weather changes all the time in India as it does all over the world. It's not every day of the year that is extremely hot. Some days are extremely hot. So the weather in Mumbai is something like this today. It's the monsoon. So the temperature is lower, and although the humidity is very high, but because the temperature is comfortable, we feel not so, we don't feel discomfort outside the building, as well as the building inside has low solar heat ingress. So, the factors that affect thermal comfort of us as people are what surrounds us. Our human body temperature is 37, our skin temperature may be lower. So, we depend on air temperature, the radiant temperature of surrounding surfaces. If you stay inside buildings which are all glass and which get very hot, the radiant temperature near the outdoors, near the edge of the building, will be extremely hot. What is the humidity inside? What is the air motion? So, ISHRAE, the Indian Society, recommended some time back during the COVID period of temperature conditions, which are now specified by the Bureau of Energy Efficiency, the Public Works Department, and the National Building Code, that between 24 and 30 degrees centigrade, dry bulb, and 40 to 70% relative humidity, depends on where you are. In Mumbai, we can have higher humidity. In Jaipur, we can have lower humidity, and we can feel comfortable in this complete range, right? So I just wish to give you some historical perspective of buildings in India, which were built many, many years ago. This is a palace in Rajasthan where it's very hot and dry. You can see 43 degrees centigrade, but the wet bulb is very low. So taking advantage of the wet bulb, there was a reservoir close by at a height. So water came by gravity through these jets, which became a fountain, and it made a pleasant environment around the building, which kept cool even during the hot summer months. As you can see, the building is at the edge of a lake, so natural evaporation cools this building as well. The Taj Mahal, the iconic building in Agra, has very hot and dry summers, but very cool winters. The temperature in the winter cools down to 5 degrees. So the wet bulb is nice and cool of the Yamuna river, which goes by the side. But the Taj Mahal rests on a very, very, very large thermal mass, which is its base, right? So that base gets gently cooled over the whole of the winter and becomes a storage of coolness, we can say. So during the hot summer months, this thermal mass absorbs the heat from above and becomes a thermal battery. So the Taj Mahal gets its cooling very easily from its large thermal mass, as well as many other features, such as trellis walls, which allow air to come in like a jet and cool the insides. Natural cooling with thermal storage. This is the institute where I studied in Kanpur. It was built many years ago in the 60s by an architect, Kanvinde and Rai from Delhi. And it had district cooling at that time, a 1,000-ton district cooling plant, which was operational till recently, which otherwise would have been 3,000 tons because of load diversity, the load comes down. So all the buildings around the central space, the laboratory, the lecture halls, the classrooms, the administration building, and the very large library were cooled by that district cooling system. There was also a nice feature called the spray pond. The spray pond served as a cooling tower, and it quite naturally cooled the exteriors because of the mist of spray around this building. Kanpur is hot and dry, and this library is set up at a very big height. So below the library is also very cool and comfortable if you sit down there next to this spray pond. Here is the Baha'i temple in Delhi, a more recent construct, which has a lotus-shaped roof, which allows heat to escape from the top, rising gently, a huge water body surrounding it, so evaporative cooling cools it. At any time of the year, it's very comfortable inside. Because of its large thermal mass, it doesn't allow extreme climate changes outside to affect its inside. Here's an old building built in 1913. It's the General Post Office in Bombay, close to the Victoria Terminus station, naturally cooled by high ceiling, large amount of cross ventilation. And of course, the good part of the building is people who are visiting don't stay all the year round, and those who are working have fans to comfort them. Here is the Victoria Terminus station, also built in the 1800s, naturally ventilated and completely comfortable as passengers walk through it and enter the trains. This is the India Habitat Center in Delhi, built more recently by an iconic architect, Joseph Allen Stein, who built many buildings in Delhi, including India International Center, and of course, all around India, in partnership with other architects, Doshi and Bhalla. So it has this nice feature of sun breakers. So solar heat comes less into the building. The building is set back. The windows are all set back. So heat ingress is completely reduced. It has very good insulation of even of the walls and the roof to allow less heat inside. And this is my last slide. This is architect Charles Correa, and he built many buildings all around the world and in Bombay. I had the pleasure of working with him many years ago in Bombay for a residential building in Bombay, which has very low heat ingress. But this is a large cultural space in Bhopal, and this space has this big advantage of bringing down the flow to allow less heat ingress at a lower level by cross shading, as well as it is right next to a large lake, so it gets cooled naturally. And so Charles Correa advocated a place in the shade everywhere you build. So if you are in the shade in hot and dry places, the temperature is very bearable, and that's how modern and ancient buildings take advantage of climate to make their spaces more comfortable. And of course, the building construction.